So what you're seeing today is by far the most difficult aerobatic maneuvers flown by any computer-controlled helicopter.
The goal is always for us to take really hard problems that humans are very good at solving. For instance, Garrett can pick up any helicopter, even ones he's never seen, and go fly amazing aerobatics. So the question for us is always, why can't computers do things like this? So our goal is to build software that can learn to go fly a helicopter the way that a human being can, and that way we don't need so much engineering effort to build control systems like this.
So the basic technology used to develop the helicopter controller was a type of AI algorithm, type of artificial intelligence algorithm called apprenticeship learning. What the helicopter does is it watches a human pilot fly the helicopter around for a while, and by watching a human pilot learn to fly, it then learns to fly by itself. And so what it does is it watches the person fly, and then it will try to fly the same stunt maneuvers by itself, and maybe try a few times until it sort of nails the maneuver. And what you're seeing is the end result of this machine learning process called apprenticeship learning.
So basically what the software does is it acquires all of the measurements off of the instruments, and then it puts them into something called a Kalman filter that figures out where the helicopter is, which way it's facing, what its velocity is, and so on. And then that information is fed into a control system that decides based on where the helicopter is and where we want the helicopter to go. The controller actually computes new controls to send out to the helicopter every 20th of a second.
What we do is we collect several demonstrations from our expert pilot, and then our algorithms process these demonstrations to figure out what would be the ideal version of, let's say, a flip or a roll or a loop, etc. And then we use that as a specification for our control problem. And this allows us to find trajectories that are better trajectories than the pilot can demonstrate.
The helicopter doesn't want to fly. It always wants to just tip over and crash. So you always have to be maintaining the orientation of it. Whereas an airplane, if you let go of the sticks, it would more or less fly fairly straight. I've never seen anything like this done. The only autonomous helicopters I've seen are just they're hovering waypoints and doing quite basic maneuvers.
In order to make these applications work well, in order for us to trust helicopters and these sort of mission-critical applications, it's important that we have very robust, very reliable helicopter controllers that can fly maybe as well as the very best human pilots in the world can. And the work you saw today, I think, took a large step towards achieving that.